as serious as yours.
What if the fundamental law of gravity we've all come to accept wasn't as uniform as we've been led to believe? This is the fascinating world of gravitational anomalies, a realm where the force of gravity seems to play by a different set of rules. Gravity, as most know it, is a force of attraction that exists between any two masses, any two bodies, any two particles. It's what keeps our feet firmly on the ground and the Earth in constant orbit around the Sun. But in certain parts of the world, gravity behaves a bit differently. These are what we call gravitational anomalies, where the gravitational pull is either stronger or weaker than what we'd typically expect. Imagine being in a place where a ball doesn't roll downhill, but instead it rolls uphill. Or a location where you feel heavier or lighter than you would elsewhere. These are not scenes from a science fiction novel, but real phenomena that can be attributed to gravitational anomalies. The key to understanding these anomalies lies in the intricacies of our planet's composition. Earth isn't a perfect sphere, nor does it have a uniform density. It bulges at the equator and flattens at the poles, and its density varies greatly from place to place. These variations in density can cause slight deviations in Earth's gravitational field, the anomalies we're talking about. For instance, the Hudson Bay area in Canada has lower gravity than expected. Why, you ask? Well, tens of thousands of years ago, this area was covered by massive glaciers. The weight of these glaciers compacted the Earth's crust, making it denser. When the glaciers melted, the crust began to bounce back. But it's a slow process. Even today, the crust hasn't fully recovered, and the lower density results in a slight gravitational dip. On the other hand, certain areas like the Nevada desert have a higher gravitational pull. This can be attributed to dense rock formations below the surface, adding more mass and hence more gravity. In the grand scheme of things, these gravitational anomalies are quite small. They don't significantly affect our daily lives, but they do have some interesting applications. They can help geologists understand Earth's interior and are used in satellite navigation systems to correct for gravitational variations. So, gravitational anomalies, far from being mere curiosities, serve as a reminder that our planet is a dynamic, ever-changing entity. They highlight the fact that even something as constant and predictable as gravity can have its little quirks, depending on where you are. And most importantly, they keep reminding us that there's always something new to discover, to understand, and to marvel at in this incredible universe of ours. In the end, these anomalies are not exceptions to the rule, but rather, they are the rule. They show us that gravity, like everything else in nature, is beautifully complex and wonderfully unpredictable. And isn't that something to ponder about?